All right, I hope I sound a little bit better. My husband gave me his work headset, so the audio quality should sound better for this. This week we were talking about 4.2, and this one is um, we're modeling real life situations. So things we were talking about parabolas last week, and they're good for different situations. So you can think of a golf ball after it's been hit, like the path it follows, it goes up and then it goes down. The arc of a bridge, so the cable system. Usually, pretty famous one is the San Francisco, the Golden Gate Bridge. There's that U shape, that's a parabola. The path of a baseball thrown from the outfield to home plate. Stream of a water fountain, so we all know what that one's kind of like a mountain. And the path of a cliff diver. So this specific scenario that we're considering is the 2004 men's Olympic shot put event, which was run by this guy in Ukraine, and he threw it 69 feet and 4 3/4 inches, and the path of the winning throw. So he throws the shot put, and it actually follows this path. Was this equation, and I'm going to highlight this so we don't forget this equation because it's the important equation for this lesson. Okay. Where x is the horizontal distance in feet from the point of the throw, and h of x is the vertical height, so how far above the ground it is. So it wants us to decide if we would want this parabola to open up or down, looking at the equation. So before we even look at the equation, we know in life when you throw something, what comes up has to come down. So kind of like this picture I drew, it's going to open down. And it wants us to explain. So if I'm specifically looking at the equation, it would be because it has a negative coefficient up front. Okay. It wants us to know what the vertical intercept of this graph of the parabola is. So remember from last week, that would be the number at the end. So 6. And it's asking us what the practical meaning is. Did it tell us? Up above, it told us it was in feet. So 6 feet. This means it started at a height of 6 feet. So the guy is probably about 6 feet tall when he started throwing it. Okay. Now it wants us to use our graphing calculator to produce a plot of the graph, and we want to see everything in the window. So I'm going to open up Desmos. I'm going to use Y instead of H. 15663. Okay, so I want to zoom out. Since I'm on the computer, I can kind of scroll out. Okay, so I can see right here, this is, let's scroll in a little bit more. I won't. Actually, I want to scroll out because I want to see where it ends. So it is crossing over here at 6. It has its maximum height right there, and this is where it crosses the y-axis. So it just wants us to sketch a graph on number 3. So I will go back to my paper. Okay, I'm only going to draw the parts that are important. Remember, we can't have negative time and we can't have negative height. So horizontal asymptotes, this was 70. 0. And our vertex was 31.922 because of word rounds. Okay, so we want to estimate the practical domain. So because we know our x-intercept is right here at 70, That is the most amount of time that can pass. Were we measuring in seconds? It didn't tell us. I'm gonna go with seconds. So my domain is gonna be 0 to 70. Hold on, I'm about to sneeze. Sorry. All right. So the reason it can't go past 70 is because we can't have negative time. I mean, height. When the practical domain means time the shot put is in the air. Is from 0 to 70 seconds. Okay, moving on to the back. It wants us to figure out the practical range. So I want to look back at my graph. It had a y height of 22. So this would be 0 to 22 for my range. And it doesn't ask us what, but I will say it reaches a maximum height of 22 feet. Okay. Then I want to go back to my graphing calculator, so Desmos, and complete the table. So remember to do that. I go to the little settings, I click convert to table, and then over here for my x values, I'm going to change them to what I need. So I need 10, 20, 30, 40, 50, and I don't need this last line. Okay, so what I want to do is I want to go write those values in to my boxes. I will do 2 decimal places because it doesn't say. So for 10, I'm going to have 14.43. For 20, I'm going to have 19.73. For 30, I'm going to have 21.90. 40, I'm going to have 20.93. No, 20.94. And for 50, I'm going to have 16.84. Okay, so I'm going to go back to my paper. It tells us that the important feature of the graph is its turning point, so where it changes from going up to going down or going down to up. So right here would be a turning point, or right here would be a turning point. Those are called the vertex of these graphs. So the values are decreasing on the left side here, they're increasing on the right side here. Over here, they're increasing, and then they hit that point, and then they start going down. Number 8 wants us to find the vertex. We found that on the front. That was 31.922. So number 9 is asking us the importance of this vertex. So at 31.9 seconds, the shot put reached a maximum height of 22 feet. Okay. Then it tells us the coordinates of the vertex can be found by rewriting the equation in an equivalent way. So the important things here, I'm going to highlight in orange, are going to be h and k. H is the x value of our vertex, k is the y value. Okay. It wants us to identify the values of a, b, and c in this quadratic equation for number 10. So a is my number out front with the exponent x squared. So that's 2. B is my number in front of the x, so negative 12. I'm going to write a note to include the sign. Okay, and then for C, it's the number without an x, so just 11. Okay. It wants me to plug into these two equations to find the values of h and k. So using a, b, and c that I found right here, I'm going to plug into h. The formula has a negative to begin with. Then I plug in my negative 12. And 2 on the bottom from the formula. My a value is also 2. Then I want to simplify, so I have negative negative 12, which gives me positive. 2 times 2, which gives me 4. H is 3. So I'm going to write that down here. Then to find x, this means, I'm going to write in green. Plug in h into the equation. Okay. So my original equation was y equals 2, and instead of x, I'm going to write 3. Ooh. I want to keep the parentheses the same color. Minus 12, and then instead of x, I'm going to plug in 3. Okay. So I could type this in my calculator, or I can actually type this equation into Desmos. So I'm going to go to Desmos right now. And I just type what I see. So I have 2 times, oops, not 30, 3 squared minus 12 times 3 plus 11. And notice right here, it gives me my answer. It's negative 7. So let's go back to my paper. And this is the value of k. Okay. So then it wants us to write the equation in the form y equals a parentheses x minus h squared plus k. So what I'm going to do is I'm going to go plug those values into, I'm going to take the a value from here, h and k from here. So I'm going to have y equals, my a value was 2, x is x. So let's use pink. X and y stay x and y. These are just letters, they don't change. So then x is here, minus my h value was 3, and my k value was negative 7. So that's all I have to do for this problem.